All right, so a little bit of background. My name is Paige Bailey. I am dynamic web page everywhere on the internet, Twitter, GitHub, everywhere. So if you have any questions about the scripts I use and the scripts that I'm kind of describing and later on in the presentation, they're all available on GitHub in the PyData folder, so take a look. I'm founder of PyLadies HText. I actually have Dorothy here in the back who is a member of PyLadies and was able to come down. I do GIS and Python development at Chevron. My background's geophysics from Rice, and I'm currently a graduate student there as well. So to get started, I guess the initial reason that I wanted to do a crime analysis was sparked by an event in my life. I was looking for a new apartment in Houston, and I'm not sure if any of you have ever been to Houston before, but the area is kind of, each segment has its own personality, right? So if you take a look in there, you can see some punk thrift shops, corporate moles living in the downtown area, saved by new hip condos, and I had very little idea of what I wanted other than it's near work, which is downtown, near my school, which is Rice, so that little beige-ish area towards the south, and also near the metro, because unlike most people in Texas, I do not have a car. So I rely on public transportation for everything. It's my lifeblood. All right, so I finally decided to settle on this location. It was near art, churches, groceries, transportation, some sort of skincare thing, so whatever happens there. And then if you take a look over here, there are coffee and tacos. So what else could a girl want, right? Like, it's everything I need, everything that a page needs to survive. So as I was moving in, my security guard kind of told me, as a side note, if you park your car outside, make sure only to park it on Fannin Street or Truxillo Street. And, you know, I just moved my last box in, and I thought that was kind of a curious statement, right? Like, so how can one side of this apartment building, this apartment complex, be more secure than another, right? So I decided to check it out to see if the statement was true, like, and how would I be able to go about obtaining that data? So the city of Houston has a department police beat crime statistics website that has monthly analyses of every single police beat district within our unit, and not aggregated in any manner. So you have 92 police beats. You have 69 months in total for each police beat, and you can go in and sort of download each CSV file individually. They also sponsor a roads shapefile as part of their enterprise GIS system via the Houston Open Data Portal. So I downloaded, like I said, manually, all of the CSVs for my police beat, and then also the city roads GIS file. I was only going to do it for a short segment, so it made sense to do that rather than writing an extended script. And doing the analysis, there's 7,445 crime entries for my particular apartment area, right, which averages out to 3 to 4 per day. So obviously pretty kind of dangerous. And then each crime has a lot of attribute data associated with it. So a date, a time from 0 to 23, an offense type, the beat number, the premise code, which is kind of like the building description, so apartment complex, grocery store, things like that, the block range, the street name, and the number of offenses for each crime. And that's just kind of an overview of what the premise code entails. So you can check to see if it happened at an apartment complex or a grocery store or a bar or something like that. So I noticed as I was doing this initial analysis, there were a lot of problems with the data. I wasn't sure if the date referred to when the complaint was filed or if when it occurred, same for the hour. There were a couple of months missing from the data set that I had to ask the police for sort of by name. Some previous month's date was intermixed, unknowns, and then also there was a change in the tabular format. Some columns moved around, but they never really changed their names. So that was the initial problem. And those are the kinds of crimes committed for my police beat. And then I also thought about some additional questions, right? So when are these crimes most likely to happen? Are they when I'm at home, or are they at night? Like, should I be walking around my neighborhood? And most seem to occur between the hours of 4 and 6, and the least between the hours of 3 and 6 a.m. And I'm not sure there's such a spike in the afternoon. It might be because so many people are heading home from work. And the number of blocks for the police beat, when I checked where the crimes were most likely to occur, it turned out that 3 of the most dangerous blocks in Houston are located right by my apartment complex. And that's actually the 3 red bars that you see there were actually the way that I would walk to work in the morning from 5 to 7 a.m. So 20.6 of crimes in the 10H40 police beat are committed in those 3 blocks really close to my apartment complex. So that was kind of scary, right? And checking to see if the guard was actually right in terms of which sides of my building were more secure. He was. The sides closest to those 3 blocks were where more auto thefts occurred, and the sides further away were at least a little bit less dangerous. So a lot of the crime happened to occur along the Metro Rail as well. So like I said, those are the most dangerous blocks, the ones marked in red. And Greyhound Station has a high crime rate as well. So which would be the most safe route for me to walk to work? Like, I was really kind of curious. Safety is a big component of everything we do in the oil industry. So there's a lot of extra effort involved in making sure that whatever you do it as carefully as possible. So when I go to work, 2 options. I have Wheeler, I have Ensemble. Both are equidistant from my apartment. And when mapped, it's easiest to see that probably the best route was to HCC, but I wanted to quantify it, right? So the current recommended route, if I want to go that way, as recommended by Google, is taking me down this path, this 4,000 Fannin to 3,800 Fannin, 1,100 Alabama to 1,000, and then down Main Street. And the total crimes along this route, whenever I did the analysis with the data set that I had pulled, was 2.15%. And then doing a weighted route analysis with the ArcGIS network analyst tool, which operates on top of Python, reduced the amount of crimes to 1.4. So the modified route that I created with Arc is moving me from my apartment complex to HCC, and the times that I'm walking to there are 4 out of 7,445 instances. So greatly reducing the amount of risk that I would be exposed to. The risk was actually reduced from the 72 walking from my apartment to Wheeler and going to work. And that's a pretty significant reduction, about 20 times, right? So this initial analysis, like I said, I was doing it for myself, but I was also doing it as part of a class project. And when I presented it, I got a lot of questions, like, it would be so great if you could do this for all of Houston. I worry so much about biking home, you know, or could you do this for the Westheimer area, right? I never know where to park my car when I go to bars. Or could you do this along the bayou? I really want to make sure that wherever I walk my dog or take my bike is really safe. So absolutely, of course, like, I would love to do this for everyone, but there's no way in heck that I was going to do it all by hand, pulling all the CSVs for the 92 police beats with 69 months of data per police beat. So that equated out to something like 6,348 CSV files just on different URLs in HPD's website. So my first thought was, okay, is this even automatable? Like, could I use automation to do this? So the URLs for each police beat are in a consistent format. They look something like this: HoustonTexas.gov/police CS stats for a given year, short, truncated month name, truncated year, and then truncated month, truncated year, and police beat number. So every single one of them looks like that. The tables and associated data also in a fairly consistent format. So if you do a right-click and inspect element, they're all within the span tag. Like sometimes the columns change configuration, but that's about it. So the pain points. Column order had to be changed depending on the date and the beat. Some months' data was unavailable because the web page didn't exist, like the URL threw up a 404. It was UTF-8 versus Unicode, or strings versus integers for the different fields, dates with dissimilar formats, unknown values versus empty strings versus NAs versus all of the different things that if you have any experience with sociological data or things like scientific data, you get a lot of different numbers for unknown items. And then the city blocks names weren't in the same format as the City of Houston's roads blocks shapefile. And if you have any experience with ArcGIS, geocoding specific addresses, if you go anywhere over like 200 to 2,000 values, you're going to run into problems and you're going to have to start paying them a lot of money. So I had no interest in doing that whatsoever. All of these, luckily, solvable with Python and some different libraries that I was able to pull in. So first of all, I created a script to generate a list of the URLs for the police beats. They aren't updated in a very timely manner. Usually there's about a 2-month delay, so I kind of solved for that and used date, time, and time. Again, all of this is up on GitHub, so if you have any questions, please let me know. But you can see there's just like a list of police beat numbers, list of months, and you cycle through them, pulling from blast. And then cycle through the list of URLs, pulling everything from the span tag. If the formatting was different, so UTF-8 versus Unicode, I used the Unicode decode error. Also request to check for 404s, CSV for being able to append to an output CSV file. Beautiful soup for the web scraping, and since they're all tables with, again, the same format, it was really pretty simple to do that. And then anything with the same column name, you just check for column name and sort of move it around. So the results. I got a final output CSV with just under 1 million criminal offenses in Houston from June 2009 to February 2015. And these aren't criminal offenses like, hey, I saw my best friend smoking marijuana in his dorm room. It's all like, hey, this is a murder. This is an aggravated assault. This is a burglary. This is a theft. Like, these are pretty severe crimes. And they're now divided into city blocks with standard formats for columns and block names, so things that you can actually use in a GIS capacity. They're compatible with the City of Houston's Enterprise Roads shapefile. And if anyone was curious, my district is responsible for 5.125% of the total crimes, despite only housing 4% of the population and covering 18 miles. So it's that really, really tiny pink block that you see sort of in the center of Houston. So what am I going to do with the data now? Like, I've gotten to the part of, I've obtained it. It's a pretty substantial file, should probably end up being a data frame or some sort of database that I house. And also, I would really like to do this for the majority of Houston. So if someone really does have that question, like, where should I park my car on Westheimer? What's the safest route for me to get to work? They would be able to answer that without having to use ArcGIS and do the network analyst tool. So next steps, I would like to incorporate the 311 data, which is noise complaints, garbage in yards, water sewage outages, and they still have the terrible monthly download by district CSV format, so ripe for web scraping. And then putting everything online with an open source GIS. So people are able to query crime rates for given blocks and route them around potentially dangerous areas. So thanks to a lot of people, but particularly the Node co-working space. They let me hang out yesterday, and I think a couple of people from there are actually here this afternoon. Open Houston, which is responsible for even putting any of the data online for me to have access to. And then also my earth science classmates for asking the questions that made me do this project in the first place. So there you go.